Hello friends, this is Praveen Pawar. In this video, we are going to discuss the question paper of UGC NET January 2017. This is paper 2 of electronic science. Here we will discuss from question number 1 to 25. So, this is question number 1. The ionized concentration for donors is given by. So, to calculate the ionized concentration for donors, here is the formula, which is Nd upon 1 plus exponential of EF minus Ed upon Kt. So here is the correct option, which is 3. Now next question is question number 2. The Y parameter of the network shown below are given as. So Y parameter is given as. So we have to calculate this matrix. Here we assume that this is the current I1 and this is I2. Okay, so here is the plus minus. We try to write the equation for the given circuit by applying KVL. We write V1 is equal to R1 I1, and from here we will get I1 is equal to 1 upon R1 V1, and from this side I2 is equal to 0, so V2 is also 0. So on comparing this equation with this, we will get the matrix this one. So third one is the correct answer. Now next question is question number 3. In a circuit shown below, the base current is. So the NPN transistor is given here. Assume that this terminal is base, here this is collector and this is emitter. We have to calculate this base current, which is IB. Okay. So here we will try to write the equation for this path. Okay, so here it is VCC is equal to RB IB plus VBE. For silicon transistor, VBE is 0.7 volt. So on putting the value of VCC, which is 12 volt, RB is 1 mega ohm, which is 1 into 10 to the power 6. We will get the current IB, which is 11.3 into 10 to the power minus 6, which is micro ampere. So correct option is second, 11.3 microampere. Next question is the output of the circuit is given by. The logic circuit is given here. This is the NOT gate. Output of this is A bar, and this is NOR gate. Output of this A plus B whole bar. Output of OR gate is the plus of both input, and here it is the NAND gate, which is the the final expression Z is equal to A bar plus A plus B whole bar into B bar plus B plus C whole bar का whole bar. By applying De Morgan's law on A plus B whole bar, we will get A bar dot B bar. Next step, we will take common A bar, so we will get 1 plus B bar. 1 plus B bar is equal to 1, and we will get A bar dot B bar. Again we apply the De Morgan's law on this, and we will get A plus B whole bar. So our correct answer is A plus B. That is the correct answer. Now question number 5. For Q to be ideal state in 8086. So here is in the table the states of QS1 and QS0 is given for different status of Q. So if it is 0 0, so Q is in an ideal state. There is no operation performed by the Q. So correct answer is 1. Next question is 6. Which of the following is incorrect reference to the array in Fortran? So its correct answer is 2. The normalized impedance of a transmission line is given by expression. So here is the formula. ZL, it is the load impedance, is given as Vmax upon Imax, and the normalized impedance Z is given as ZL upon Z0. So correct answer is 4. Here this is the ZSC.ZOC, under root of this is the characteristic impedance of transmission line. So normalized impedance of transmission line is given as this formula. Now question number 8. Which of the following is associated with single balanced modulator circuit? In this diagram you can see that the single balanced modulator or mixer is used to generate double sideband suppressed carrier signal. So its correct answer is this 2, double sideband transmission. Now next question is question number 9. A FM kilocycles per second modulating frequency provides MF is equal to 2 significant Bessel function, that is n is equal to 4 in FM wave. What bandwidth is required for passing this wave keeping del f constant? If frequency of modulating signal is double, what will be its effect on MF? So from the formula of this M modulation dex, which is equal to del f upon FM. So by keeping del f constant, just double the FM. So from here we will observe that M is reduced to half of its original value. So correct answer is 3rd. Another thing was asking this question that what bandwidth is required for passing this wave. Easily we can find the bandwidth using Carson's rule, which is equal to 2 into del f plus FM. Now question number 10. The Nyquist plot of a system is given below. You have to find the type of the system. The system is of type. Okay. So here is the figure I will show you. So easily you can say about what is the type and order of the system. Okay. So at omega equal to 0, it starts from the infinity. At omega equal to 0, any plot starts from this direction, it would be always type 0. If it starts from this, it would be type 1. It starts from this, it would be type 2. It starts from this angle, it would be type 3. And that plot will end at this origin or here, then it would be order 1, it will be, and here at it will be order 2, order 3, this is for order 4. Particularly this is for polar plotter. Okay, so from the figure we will compare, it is starting from here and ending at the origin. So this is type 1 and order 3. The system is of type is 1 system. Now question number 11. In a half wave rectifier, the open circuit voltage from the secondary of the transformer is Vs is equal to Vm sin omega t. Then the peak value of load current will be Rf is dynamic resistance of diode and Rs is resistance of transformer secondary. So correct answer is 2. Vs upon Rs plus Rf plus Rn. Now question number 12. Read the following statements regarding a typical filter. The characteristic impedance of a filter must be chosen such that filter may be fit into a given line. The cutoff frequency of a filter demarcates the pass band and the stop band. A typical filter must have very high attenuation in the pass band. Typical filter must have very low attenuation in stop band. Which of the above statements are correct? So the characteristics impedance of a filter must be chosen such that the filter may be fit into a given line. This statement is correct. Here I will draw the uh, graph for ideal filter. So here this is the upper cutoff frequency and this is the lower cutoff frequency. The cutoff frequency of a filter demarcates the pass band and the stop band. Demarcates means separate. So this frequency separate the pass band and stop band. This is our pass band and the rest of the is stop band. Okay, so this is also stop band. So from this band we extract the information. Okay, so our cutoff frequency demarcates the pass band and the stop band. So this statement is also correct. A typical filter must have very high attenuation in the pass band. Attenuation refers to the degradation or reduction in the strength of the signal. So in the pass band, this attenuation should be at the low level. So this statement is not correct. And similarly, we can say in the stop band, the attenuation will be high. So here it is given very low attenuation in stop band. So this statement is also incorrect. So correct statement is A and B. Next question is question number 13. The voltage gain of a bipolar junction transistor in common emitter configuration is. So voltage gain for BJT is given as minus HFE RL upon HIE. So A is the correct. So of the above statements, A is correct but B is wrong. So correct option is 1. Next question is, the binary number 110011 is to be converted to the gray code. The number of gates and types of gates required are. And to find the correct answer. So the given binary number is 110011. Here how we convert from binary to gray. So to convert from binary to gray, we take the XOR of the first number with the second number. So first number we will write as it is and then we take the XOR of 1 with 1. So it would be 0. Next XOR of 1 with 0. So it would be again 1. XOR of 0 0, it would be 0. XOR of 0 1, it would be 1. And XOR of 1 1, it would be again 0. So here is the conversion of binary to gray. So to convert this given binary number, we required 1 2 3 4 5 XOR gates. So correct answer is C and D. Correct option is third. Next question is question number 15. In microprocessor 8086, the 8086 is a 16-bit processor with 16-bit internal and external data bus. So the instruction queue length is of 4 bytes while entering halt in min ALE is delayed. The control pin in 8086 is MIO bar. Out of the following, which one is correct? So 8086 is known as 16-bit processor which can execute 16-bit data at a time. So it has 16-bit internal and external data bus. So this statement is correct. The instruction queue length is of 4 bytes. The instruction in a 8086 microprocessor, there is an instruction queue which is have 6 registers uh, of each of 8 bits. So its length is 6 bytes. So this statement is incorrect. While entering halt in minimum mode, ALE is delay. So halt instruction is used to pause the operation. This statement is also not correct. The control pin in 8086 is MIO bar. So this is correct statement. M is active high and IO is input output is active low. So correct answer is A and D. Third one is the correct answer. Next question is question number 16. Operation A is equal to A into B plus A can also be written as. So correct answer is C. It can be also write as A is equal to B plus 1 into A by taking A common. And similarly we can write this also. Here is the operator A into is equal to B plus A. So correct answer is C and D. Third one is the correct answer. So next question is question number 17. A lossless line has a characteristic impedance of 50 ohms. It is terminated in a load resistance of 75 ohms. The line is energized by a generator which has an output impedance of 50 ohms and an output voltage of 30 volts. The line is assumed to be 2.25 wavelength long. The input impedance and instantaneous load voltages are given. So input impedance is given as Z0 ZL plus J Z0 and beta L upon Z0 plus J ZL and beta L. Here from the question, this 50 ohm is the characteristic impedance which is Z0 and this load resistance, this is ZL, and beta is given as 2 pi by lambda, and we take L as lambda by 4. On putting these values, we will get input impedance 33.33 ohms. So C is the correct answer. Using this 33.33 ohm input impedance, we can find the instantaneous load voltage. So 33.33 divided by 50 plus 33.33 into 30 volt. So here we will get the instantaneous load voltage which is 12 volt. So correct option is 3, C and D. Next question is question number 18. Which of the following statements are incorrect? So next question is question number 18. Which of the following statements are incorrect? In a frequency modulation system, the frequency of the carrier wave is varied in accordance to the frequency of the modulating signal. So this statement is correct. In a PAM, there is a greater peak power compared to conventional amplitude modulation systems. This statement is also correct. In a PCM, the sampled amplitude is directly taken for conversion to a codes of pulses. So this is incorrect because in pulse code modulation PCM, after sampling we quantize it to convert it into levels and encode it and then send it in the form of digital codes. So after sampling we quantize it. The noise in a PCM system is reduced by increasing the number of quantizing levels. As we know that signal to quantization noise ratio is directly proportional to the number of bits in quantization within quantization. So this statement is also incorrect. So correct option is second. Where C and D are incorrect. Next question is which of the following statements are correct? ASK, which is amplitude shift keying, gives a maximum probability of error. So this statement is correct. FSK is also known as on-off keying. So this statement is incorrect. On-off keying is for ASK. In DPSK, no synchronous carrier is needed at the receiver. So this assignment is correct. Here is the advantage of DPSK, differential phase shift keying, where carrier synchronization is not required. Probability of error in DPSK is less than BPSK. Another advantage of DPSK over BPSK is that it reduces the probability of error. So this statement is also correct. A, C and D are correct. So correct option is 1. Read the following rules to sketch the root logic using poles and zeros of GH. So here I will show you, when you plot the root locus, this starts at the poles and ends at the 0. So from the options, it starts from the poles and ends at the 0. So A and C are correct. Correct option is 3. Next question is question number 21. Match the following list. So from list 1 we have to match to list 2. So in the here the D, this is the law of mass action. We know it very well. This is NP is equal to Ni square. Charge and neutrality conditions. So it is given as this Na x1 plus Nd x2. Junction built-in voltage PBI is given as Kt by Q, natural log of NND upon Ni square, and junction depth is given as this formula. So correct match is fourth one, 2, 3, 1 and 4. So correct option is this. Next question, question number 22. We have to match from list 1 to list 2. Here the Fourier transform of this time domain function is given. So Fourier transform of 1 is 2 pi del of omega. The Fourier transform of this unit step function u of t is pi del of omega plus 1 upon j omega. This is impulse function del of t. Fourier transform of this is 1, and Fourier transform mod of t is minus 2 of omega square. So correct option is 4, 1, 2, 3. Here in the option 1, this is 4, 1, 2, 3. Here in question number 23, in the list 1, the name of scientists are given here. We have to match it with this 2. So William Shockley has got the Nobel Prize in physics for the invention of transistor. So correct option is BJT. Kilby is also known as Jack Kilby, also got Nobel Prize in physics for first IC. So it matches integrated circuits. Isaki is related to tunnel diode, which is also known as Isaki diode, and this Lillian field is related to MOSFET. So correct option is 1, 3, 2, 4. 1, 3, 2, 4. So correct option is 2. Next question is, in this list 1, the IC number is given and we have to match it with the IC. So 7400 is for NAND gate, 7402 is for NOR gate, 7408 is for AND gate, and 7432 is for OR gate. So correct option is 4, 1, 2, 3. Correct option is second. Next question is question number 25. Here is the control register port A, port B, port C. 8255 is known as Programmable Peripheral Interface Chip PPI. So its port address is given here. The control register is for 11. The port A address is 00. Port B is 01 and port C is 10. So correct option is this 4, 2, 1 and 3. Okay. Thanks for your kind attention. Your all suggestions are most welcome. Please like, share and comment and subscribe my channel Praveen 25488. All the best.